In today's lesson, we're going to take a further look at triangles, in particular right-angled triangles, ones that have a 90-degree angle on them. And we're going to look at the relationship that exists between the three sides. There's kind of a cool relationship that always happens if you have a right triangle. And just a reminder, with right triangles, you know it's a right angle because it has that little box in the corner. It's kind of our big idea. Okay, here's how the relationship works. The longest side, which we're going to call the hypotenuse, can always be related to the other two sides. Okay, fancy word, the hypotenuse? You know where it is because it's always across from the right angle. It's always the longest side. The other two sides, we're going to call them the legs. Okay, we're going to call them A and B. It's how I'm going to label them. And the hypotenuse I'm going to call side C. So if this is my right angle triangle, here's the right angle. That's side C. This is side A and B. Now, A and B are interchangeable. I don't really care which one's A, which one's B. I'm going to call that one A, this one B. The only one that really matters is side C, and has to be across from the right angle. Here's how the relationship works. Every time, always, 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 A squared plus B squared comes out to C squared. So if you take your two legs, I'll show you an example right here of that triangle. 3, 4, and 5, my two legs, so A squared, plus B squared, equals C squared. A reminder with our calculators, I have a big old calculator here. When I square something, and I'm doing 3, and then I use my squared button. There's one right here. Oops, sorry. Just to show you, there's one right here. There's a squared button. Or you can use your exponent button. That's the one up here. The power of. That's how we can square things. So we can do 3 squared, comes out to 9, plus 4 squared, which comes out to 16. Add them together and it comes out to 25, which happens to be the same thing as 5 squared. Now, why is this relationship really useful? Well, if I know any two of the three sides, I can always figure out the third side. And I can do that using my idea of algebra. Numbers on one side, letters on the other. And that's going to be our big objective today. So let's give this a try. So, how does this formula work? My two short sides, when I square them and add them, have to come out to the third side. So we can prove if things are actually right angle triangles or not. So if these are my three numbers, we call this a triple. Okay, the 12 and the 15 have to be the short sides, and the 20 has to be the long side. Let's see if it works. What is 12 squared plus 15 squared? Does it actually equal 20 squared? So using my calculator, I'll clear this one. Go to the ink. All right, 12 squared is 144. And 15 squared is 225. 20 squared is 400. I'm following bedmaster rules here, right? Exponents before addition. Well, if I add these two things together, I get 369. That's not 400. So could this be a triangle, a right triangle? Not right. They're not equal. This wouldn't actually work as a triangle. Okay, try the second one here. Now, if I had 9, 40, and 41, which sides matter? A and B go whichever sides you want to, but C has to be the long one. So if we try this one, A squared, B squared, C squared, 9 squared is 81, 40 squared is, 1600. And it turns out that 41 squared is 1681. Well, if I add them together, I get 1681. Hey, those are the same things. What does that tell me? This is a right triangle. And you try the last one. 8, 10, and 12. 8, 10, 12. That's my long one. 8 squared, 10 squared, 12 squared. Let's see if it works. 64 plus 100 is 144. Well, those are 164. That's not 144. This is not right. So we now know if something is true or not based on the numbers. Well, what happens if we have the diagram and we want to find the numbers? Let's have a look at some of those. So the same idea, except for now not knowing the third side, I'm going to solve for it. So how do I start? I'm going to label them A, B, and C. Which is the ones that matter? A and B. Interchangeable. C is the one that matters. So A squared plus B squared equals C squared. Okay, so our objective is numbers on one side, letters on the other whenever we solve for a missing letter. Well, that's what we have. So here we go. 8 squared is 64. 6 squared is 36. C squared, we don't know. We can collect our numbers and get 100 for C squared. Now we don't want C squared, we want C. How do I do this? Well, I have to get rid of a squared. The opposite of squaring something is square rooting something. Okay, at the button on our calculator, we've got to find it, something new. Okay, so on our calculator, you see it's red. Nope. Right there. Okay, and we have to use our second function. Second function to get to it. Okay, so I'll show you how that works. We're going to press the second button up in the top corner, and then the one looks like a square root. Put our number underneath. The square root of 100 is 10. There's our value for C. That's how long the hypotenuse is, the longest side. Okay, we're going to try the exact same question, different numbers. Let's give this one a try. So A and B are interchangeable, and call this A and this B. There's the one that matters. That has to be side C. So A squared plus B squared equals C squared. Numbers on one side, letters on the other, just the way we want it. 12 squared, that's 144. 25 squared is 25. I don't know what C squared is. I'm going to add my numbers together. I don't want C squared, I want C. So I'm going to have to square root, and C is 13. Okay, so far so good, hopefully. Okay, we'll try one more of these things. Okay, this one's slightly different in terms of, well, the picture looks a little bit different, and in terms of this one's not going to work out so nicely. Okay, where's the important side? Side C, A and B. So 14 squared plus 27 squared equals C squared. Let's get our calculators out for this one. 14 squared is 196. 27 squared, that's a big one, 729. It's okay to get big numbers, nothing wrong with that. Add them together, you get 925. That's C squared. We want C, so we need to square root. And in this case, we're going to end up with 30.41. Try and keep 2 decimals if you can when you get the decimal ones. And that's okay. In fact, most of these questions are decimals. It's very rare you get a nice perfect square root. Okay, so that's a big idea. Let's see how we can apply it once. Okay, to walk around the schoolyard, Jill first needs to walk 30 meters north, then 60 meters east. How much shorter would it be to walk through the yard? So she's got to walk 30 meters north, and then she has to walk 60 meters east. How much shorter would it be if she could just do this? Well, doesn't this look like a right angle triangle? Can we not find side C? It's my hypotenuse. If I know A and B, I think so. A squared plus B squared equals C squared. So I got 3,600 plus 900 is C squared. That's 4,500. That's for C squared though. I just want C. I square root it and I get 67.1. That's side C. Now is that my answer? What was the question? How much shorter would it be to walk through the yard? So she can go this way, it's only 67.1, but she actually has to walk north and then east. So how far did she walk? She walked Well, 30 plus 60 is 90 meters. She really could have walked this short distance. How much further is that? Well, 90, take away 67.1, comes out to 22.9. Okay? The shortcut is 22.9 meters shorter. That's a perfect use of Pythagoras. We use Pythagoras when we have missing sides in a right triangle. In our big formula, we need to know a squared plus b squared is c squared, where c is the side that really matters. Say